Hello students, in this session we will discuss about applications of stack. So stack is used in different application areas such as evaluation of arithmetic expressions, code generation for stack missions, implementation of recursion, record management, etc. Now, as per our syllabus, let us consider this application, evaluation of arithmetic expressions. In computer system point of view, whenever we submit an arithmetic expression, it works with the combination of two stages. Here, first, it converts the given arithmetic expression from infix to postfix notation, and then in second stage the postfix expression is evaluated. In both stages, stack is an important tool used to perform the specific task. Now observe this example. Assume the given arithmetic expression is 2 plus 3. So here in first stage 2 plus 3 is converted into postfix notation format like 2, 3 plus. In second stage, the postfix notation acts as input. Now it produces the result value as 5. In these two stages, computer utilizes stack data structure. Now observe the first format, stage 1, conversion of infix expression into postfix expression. Now assume Q is an arithmetic expression which consists the operators like plus, minus, asterisk, division and cap symbols. In addition to these operators, left and right parentheses are also available. Now for these operators, assume the priority order as cap symbol has highest precedence 3, asterisk and division has same precedence 2, plus and minus has same precedence as 1. Now observe the procedure. Here this procedure converts the infix expression Q into postfix expression P. Here step 1. The procedure starts by inserting a left parenthesis into the stack and add a right parenthesis at the end of the infix notation Q. Step 2. Scan the elements of Q from left to right and repeat steps 3 to 6 for each element of Q until the stack is empty. So to implement step 3 to 6, every time we check whether the stack is empty or not. Here, based on the scan elements, the element is either an operand, operator, left parenthesis and right parenthesis. So based on these four categories, now we design the steps as step 3. If the scan element is an operand, simply place the operand value into P. If the scanned element is a left parenthesis, push it into the stack. Step 5. If the scanned element is an operator, now repeatedly pop elements from the stack and add to resultant expression P, which has same precedence or higher precedence than the scan symbol. Finally, add the scan symbol into the stack. Step 6. If the scan element is a right parenthesis, now repeatedly pop elements from the stack and add to resultant expression each operator until a left parenthesis is encountered. Remove the left parenthesis. Now step 7, exit. Now observe this example. Convert the infix notation 2 plus 3 into postfix notation. Now based on the procedure, first given infix notation q equivalent to 2 plus 3. Now we add a right parenthesis at the end of the expression. Now we design this table format: scanned element, stack, postfix notation, remarks. Now step 1, push a left parenthesis into the stack. Now we scan elements of q. Here the first element is 2. Now 2 is an operand, hence put it into the resultant postfix expression. Next scanned element is plus. Now plus is an operator, hence in remarks column first write down the priority of the scanned element plus. Here the priority is 1. Now we delete an element from the stack. Here the deleted element is left parenthesis. For this priority is 0. Now compare these two priorities. 0 is greater than or equivalent to 1, false. Hence again put left parenthesis into the stack and then the new scanned element plus into the stack. Then next scanned element 3. 3 is an operand, hence put it into the resultant expression. Then next scanned element right parenthesis. So when the right parenthesis is encountered, repeatedly pop elements from the stack and add it to P until a left parenthesis is encountered. So here the first deleted element is plus, which is not a left parenthesis, hence it is added into P. Next element left parenthesis. Left parenthesis arises, simply remove the left parenthesis. Here no elements are available. Now the status of the stack is empty. So whenever stack reaches to empty, now the resultant expression is 2, 3 plus, which is available in P. So this one postfix notation for the given infix notation 2 plus 3. Now stage 2, evaluation of postfix expression. Now suppose P is an arithmetic expression which is available in postfix format. Now the following procedure evaluates the expression and produces the resultant value. Here stack is used to hold operands. So procedure: step 1, first add a right parenthesis at the end of the expression P. Step 2, scan P from left to right and repeat steps 3 and 4 for each element of P until the right parenthesis is encountered. So in case of postfix notation, when we scan the element is either an operand or an operator. So here step 3, if the scanned element is an operand, push it into the stack. If the scanned element is an operator. So at this stage, first remove two topmost elements from the stack. Assume A is the topmost element and B is the next two top element. Now evaluate the operator procedure as B operator A. Now it generates some resultant value. Now this result value is placed back into the stack. Step 5. Whenever a right parenthesis arises, now set result value as the topmost element of the stack. Now exit. Here observe this example. Evaluate the postfix notation 2, 3 plus. Now given postfix notation P equivalent to 2, 3 plus. Now as per the procedure, first add a right parenthesis at the end of the expression. Now we design a table format with 3 columns: scanned element, stack and remarks. Now scan each element of P. So first scanned element is 2. Now 2 is an operand, hence it is placed into the stack. Next element 3 is an operand. place into the stack. Next scanned element plus. Now plus is an operator. Now go to remarks column. Now first delete an element from the stack. The first deleted element is 3. Now 3 is stored in A. Next deleted element 2 stored in B. Now the type of the operation B operator A. Hence 2 plus 3, the result value is 5. Now again place 5 into the stack. The next scanned element is right parenthesis. Here right parenthesis arises, hence the result value is topmost element of the stack, which is 5. Therefore resultant value is equivalent to 5. So in this way, an arithmetic expression is evaluated with the combination of infix to postfix conversion and then evaluation of postfix expression. In both stages, it utilizes stack data structure. Now finally, stack disadvantages. Now observe, at one particular stage, if the status of the stack is in this format, here 3 elements are available, 10, 20, 30. Here the topmost element of the stack is 30. Here the first inserted element is 10. So if you are interested to delete the first inserted element, direct deletion is not possible. Here stack allows deletions operations at the same end. So if you are interested to delete 10, direct deletion is not possible. First delete 30, 20, then 10. So after deletion of 10, again we insert 20 and 30 into the stack. For this, it takes more time. So at this stage, it leads to time complexity problems. So to overcome this type of disadvantage, it is better to go for another type of data structure known as queue data structure. Thank you one and all.